Okay, let's review some of the concepts we learned about probability. And let's just begin with exercise 1, where we have the results of a survey. And from that survey, we need to identify certain probabilities. So 100 people were surveyed. And in that survey, they were basically asked, please check if you eat beef, or if you eat fish, or if you are a vegan. So you can think of a survey where there are like things you can cross, and some say beef and fish, and others say vegan. And once we tally that up, so there are like many people who filled that out, so that is like the survey that 100 people filled out. And then when we sum it up, so 100 surveys were filled out, so we get the result that 7 times people checked beef, 50 times people checked fish. Well, and now here you can already see that some people must have checked both beef and fish, and 10 said they are vegan. And so vegan is someone who neither eats fish nor beef. Okay, so because vegan is 10, what we know is that the union of both is written as the probability of beef union fish. That must be 90. And so that means that if you have 70 and 50, that's 120. So that's 120. So that means that 30 must have said that they eat both. So that means 30 must have checked both beef and fish. And that means beef only, that's 40, and fish only, that would be 20. So obviously the events are not independent, and so what we know is that the probability, so how did we get those numbers? We said the probability of beef union fish, so we know that this is 90. But from the addition rule of mutually non-exclusive events, we know that the probability, the rule is for a non-exclusive event, the probability of beef plus the probability of fish minus the probability of beef and fish. Well, all we know is that because 100 were surveyed, 10 are vegan, that means 90 must eat beef and fish. So that is 90. So that is 90. And so what do we know? We know that 70 people said that they eat beef, so that was 70. 50 checked fish, so now we can infer that 30 must have said they eat both beef and fish. Okay, So in this case, the probability of beef, so that's all in percent, that is 70. So that is simply the probability that somebody who is randomly selected from the population eats beef. They also may eat fish though. But the probability that somebody eats fish, well, that is the 50. And again, some of those also eat beef. So what's the probability that somebody is not a vegan? So vegan prime is somebody's not a vegan. Well, that's the union. So that's definitely aged, because the union of beef and fish, that's 90. And it is 90, so both A and B are correct. Are eating beef or fish mutually exclusive events? Of course not. They are not mutually exclusive. So depends on whether the fish has bones. Nah, that's stupid. Yes, always. Only if the fish is served in a white wine sorbet sauce with freshly cut basil and the beef is grilled medium rare. So the answer is no. Okay, let's move to the other questions. So now from the addition rule of mutually non-exclusive events, which is the probability of beef or fish, which is the probability of beef and fish minus the probability of beef and fish, it follows that the union, well, we already calculated that, that's 90. From the addition rule of mutually non-exclusive events, which is, it follows that the probability of beef and fish, well, that's the 30. What's the probability that somebody eats meat, either beef or fish? Well, the correct language is the union. So this one conventionally reads as and, but of course the statistically correct terminology would be intersection, and this typically reads as or, but the correct terminology is union. So what's the probability then that someone eats beef and fish? Okay, so that's the probability of A and B, that's correct, and it is 30. So in this case, both is correct, both B and C. Given that someone eats meat, what's the probability that someone eats fish? So if we write that, that's the probability that somebody eats beef, that's event A. Actually, no, we are here. Probability, given that someone eats meat, what's the probability that someone eats fish? So given that they eat meat. Okay, so what's the probability that given that they eat meat, that they eat fish? So given that they eat meat, that limits everything to the 90. 90 people eat meat, either beef or, so that's the union, and we have to subtract the intersection, but 90 people eat meat. So the probability that somebody who eats meat eats fish, so that would be 50 over 90. So both languages are correct, both. Actually, both. Okay. Okay. So given that someone is not a vegan, what's the probability that someone eats meat? Okay. So given that somebody is not a vegan, well, then they eat meat should be 1. And we can write that as the probability that someone eats meat given that they are not a vegan. And that is 1, right? Because if they're not a vegan, they fall into that bubble. So we can write it as meat given vegan prime. And since that is a conditional probability, it can also be written as the probability of m times the probability of vegan prime over the probability of vegan prime. And this term is nothing else as the probability of m and v prime. So all of the above are correct. Okay, so let's stop here. So we have now reviewed again a little bit some terminology. And yeah, I'll just make a separate video for the next exercise, and I'll just stop here and hopefully see you in the next video.